Hello, my name is James Kemper, and I teach economics for South Plains College, as well as an adjunct for Wayland Baptist University. And this particular video blog really isn't about economics. Sometimes we do look at limits in economics, but not necessarily what I'm about to show you. However, I did have a student come up to me the other day and ask if I could help them with their math class, and they're interpreting graphs associated with limits. And so I thought I could do my best. Now, I'm not a math teacher, and your math teacher could probably do a much, much better job. But we don't all speak the same language, so maybe you're having a difficult time understanding your math teacher, and this video might help you. So this is an example equation or problem that a particular student sent me. I'm going to do my best to kind of explain what they're asking. Hopefully I get it right. I don't have the answers, so I'm going to do my best to provide you the answers. So let's look at this graph first in this particular limit. What we see right here is this graph is f of x, and we have multiple linear equations. These lines represent various curves and various formulas. And what we're trying to figure out when we talk about limits is how close we can get to a particular point. A limit isn't actually that point in of itself, it's how close we can get. Now there are two types. One is right-handed, and you will see the notation like that, plus sign next to the 3. So if it's x approaching 3 with the plus sign, that means it's right-handed, and that means we're approaching the point of x from the right. You will also see negative sign, which is left-handed, and that means we're approaching from the left side. So if it was x approaching 3 from the left hand, then we would see something notated like that. That's very important to note. It's not really the direction in which these linear graphs are going or these curves are going. It's more how we approach x from the particular side. So in this example, let me clear everything out. What we're looking at, is f of x, which is just a function of x, as we get close to or equals negative 3. All of these have to do with negative 3 as we're approaching negative 3. So what that tells me is that I need to focus on the x-axis, which is this axis right here, and go over 3 spaces because it's negative 3. So if this is 0, right here, I go over 3 spaces, 1, 2, 3, and on that point, and fortunately this example actually gives us grid lines, so it makes it much easier. That's negative 3. All up and down there are y points where x is negative 3. So where x equals negative 3, y might at this point equal 1. So that would be written as negative 3, 1. At this point, y would be negative 2, etc., etc., etc. But we'll go through that as we look at the graphs. So, looking at this, we really only need to focus on that one particular point on the graph. So, what I can see is that a couple of these curves won't even hit x equals negative 3. This one for sure, since it's all positive, everything from this point on is positive regarding x. That's definitely can be excluded as far as the graphs we're looking at. And since negative 3 is right here, I can eliminate these two curves as well. Guess that might be a parabola of some sorts. It may be two separate linear equations actually that are just meeting, and it may be defined. However, what I can tell is that the only ones I really need to focus on are right here, because they hit that point of negative 3, as well as this dot right here. That actually hits negative 3 on that line. So that's all I have to focus on, is this right here. Everything else I might as well forget for this particular equation. Alright, Now let's move to the next step. On A it says, and it's hard to see, it's the limit of f of x as we approach -3 from the right-hand side. Plus means right-handed side, and negative, the minus sign, means left-handed side. So what that means is if I'm coming from the right, I'm going this way as I get closer and closer and closer to -3. Left hand, coming this way as I get closer and closer to -3. So this particular equation, since it's right hand, what I'm saying is on the particular graph, what is the point as I get really, really close to -3? And you'll see at this one, what I'm doing is I'm coming this way on this graph, and as I get closer and closer and closer, what will I hit? Now we just round to the point that's the closest. It would actually be -2.9999 because we're coming from this way, so it's going to be greater than -3. But for the limit, we say as close as we possibly can would probably be approximately right here, which on the y-axis is down 0, 1, 2 spaces. So my answer for A would actually be the limit of f of x as I approach -3 from the right hand side is -2. Now let's go on to B right here. So what is the limit of f of x as x approaches -3 from the left hand side? Well, in this case, what I'm doing is I'm going from the left to the right. I'm coming from the left. I'm coming from the left hand side. And so this curve is actually on the left hand side of this point. So I'm going to go this way. And you'll see that point still is the same point, right? At -3, x equals -3. I hit y equals -2. So that would be -2 for this one as well. Or, sorry, I put it on C. That would be -2 for B. So the answer for B would be -2. Now, the limit of f of x, where it says just as we approach -3, what it's talking about is, do the right hand and the left hand line up? In other words, are these equal? So we've got -2 and -2, and so therefore those equal each other. We would say that this is defined and it exists. And so we would say it's -2. Now, if for whatever reason this was 4 or something like that, then it wouldn't be defined. Now, I'm not 100% sure exactly how your professor wants you to write this or answer that, but I think that's how they want that it's defined. Alright. However, even though that might be -2, what we know is that when f of x actually equals -3, we don't see y equal -2. So that's the last one, part D. So f of x actually equals -3. This is where x actually equals -3, and it's not approaching -3, it's just equal to it. Well, if we go over 1, 2, or sorry, I keep doing that, 1, 2, 3 spaces, we see that there's this circle here, right? That circle means it's not technically defined at that point. So even though we're saying that it's defined and it's -2, in reality we'd redefine it as y equals 1 because we hit that point. That means there's a spot in our equation, whatever it is, if it was, let's say, and this is not going to be accurate, but x equals not that, let me do it this way. Let's say 3x plus negative 3.5. So we intercept right there, and we're having a slope of 3 over 1, and that's not 100% accurate, but what we would say is that we'd actually have another part of that equation where that's only if x is less than a certain amount, like negative 2, f of x, and I know I'm getting kind of ahead of myself here, it's just a splitwise function, and we would say, well, if x actually, or an x is greater than negative 2, keep doing that, x is greater than negative 2 or less than negative 2, then we'd have this particular formula. However, if it's if x actually, it's not that, it's 1. So if x actually equals negative 3, then we'd have 1. And I don't know if I've lost anybody or not, but that's a little bit more complex, and that's just a splitwise formula in which we actually have this non-continuous point. So going back to D, it would actually be 1, because if x equals negative 3, 1, 2, 3, we see that there's that point, it's up 1, y equals 1. Could be written as negative 3, comma 1. Alright. Hopefully you enjoyed this. If it helped you, good. If it didn't and it confused you more, sorry, don't tell me about it. Go ask your math professor. Good luck. And as always, ask me any questions you might have. You can either email me at jkemper@southplainscollege.edu or hit me up on Twitter at Mr. Kemper.